So this is combinatoric expression. So the 12 crystals heirs of Alpharius are seated around a round table. So I'll draw that round table now. Note that since this is a round table, um, rotations are considered the same. So if I rotate the table, then that would still count as one arrangement. And all heirs are distinct. Due to internal conflicts, the following conditions must be satisfied. Anaxa and Aglaia must sit directly opposite each other. Hyacinth must sit adjacent to Aglaia, and Final and Maide must not sit next to each other. Let n be the total number of distinct seating arrangements that satisfy these conditions. Find the remainder when n is divided by 1000, or in other words, find the last three digits of n. So first I'll draw this round table so we have a visual. So I'll give you guys maybe a few minutes to think about the question. Okay. Uh, Seems that there is nothing in the chat so far. Anyway, let's go over the question. So again, as I said, rotations are considered the same. So basically, so that we don't have to deal with over 12 anymore, let's fix one of the people already in their seats. So for brevity, I'll just number the people. So this is 1, 2, 3, 2 again, 4 and 5. So in the diagram, I'll just refer to them by their number. So notice that we can fix 1, then the seat of 2 is already determined. So number 2 is seated directly opposite already, right? Then 3 has two options on where they could seat. So either here or here. So we already have a factor of 2 in our in our expression for for n. Okay. So it's n equals 2 times something. Okay. Then there's one more condition which we haven't treated yet, which is these two must not sit next to each other. What I'll do here is kind of complementary counting. So let me start by asking a question. So let's assume for now that 3 is seated here. So basically, these 4 seats and these 5 seats are not yet occupied. So what is the total number of ways that the two the two others can choose their seats. Yes, just them. We're gonna do like a complementary counting approach here. Not 9 factorial since there are just two people. 9 factorial is basically like the number of ways to arrange everyone else. Okay. Uh yeah, so it's 9 times 8. Basically because yeah, this is the intended solution actually. The 9 is basically the number of ways that the first person will choose, and then 8 is for the second person. And so we have 9 times 8 here. Now we wish to remove the people who no. We wish to remove the cases where the two of them sit together. So how many ways are there for them to sit together? Yeah, so 14. Note that there are 7 possible pairs of seats that they could occupy. So it's these 3 on the left and these 4 on the right. Okay. And there are 2 ways for them to occupy the seats. So if one is on the left and one is on the right and vice versa. So 9 times 8 minus 7 times 2 for the two of them. Basically, the 9 times 8 minus 7 times 2 is the number of ways that they can occupy the seats such that they don't sit together. And lastly, we have the other 7 people, who have no restrictions, so we just put 7 factorial, since that's the number of ways that we can arrange them. Yeah. I'll spare you guys the calculation. The last 3 digits here should amount to 640, which is the final answer. Note that during contests, I would also recommend that you kind of know at the back of your head the first few factorials. So for example, I immediately know that 7 factorial is 540. 5040. And so calculation is kind of faster. But of course, if you still have time, you can just derive it to make sure.